third grade Cougars, it's Mrs. Belatash, and I'm here today to start talking about magnets. Oh, I love magnets. I have loved magnets since I was a little girl. I just think they're so magical. So we're gonna do some things with magnets, but I also wanna make sure that you watch the Brain Pop Junior. I know it's Junior, but the other Brain Pop is too long and too complicated. So I want you to watch Brain Pop Junior, the video on magnets, okay? Now, let's investigate with some magnets. Okay, so boys and girls, I have two magnets. They're called donut magnets. Don't eat them, they're not to eat, but they are round like a donut. So this is the interesting thing. If I put these two magnets close to each other, ooh, these two magnets do not want to touch each other. You see how it pushes the other one away? So we say that when two magnets push away from each other, they repel. Now I'm going to flip one over, and now I'm going to get them close to each other. Oh, and this time, instead of repelling, they are sticking together. So we say that when two magnets stick together, that they are attracting, okay? So magnets can attract, come together, or magnets can repel or push away. So they can push away, repel, or come together and attract, okay? Now, the question is why? Why do magnets do that? So this time, instead of having a donut magnet, I've got some bar magnets. It's called a bar magnet because it's in the shape of a bar. And I don't know if you can see this, but on one end there's an N, and on the other end there's an S. And that means north, and that means south. So let's see what happens when we put these together. So this is an S, and this is an S. So two souths. When I put two south ends together, uh-oh, they don't like each other. They are pushing each other away. Okay, whoopsie. So it actually makes it flip around. So two south poles together, they don't like it, okay? Let's try two north poles together. Oh, they don't like it either. Nope. Okay, so when we have two south poles, they repel. When we have two north poles, they repel. Now, let's put a north and a south together. Boom! North and south comes together. We say that opposite poles, north, south, attract, right? Opposite poles, north and south, attract. The same poles, north and north, oh, they repel. The same poles, south and south, they repel. So let's talk about why those things were happening with the magnets, okay? So again, first of all, there's two words that we really need to think about this time. So we've been talking about pushing and pulling before when we talk about forces. But now, when we talk about a pushing force, we're going to call it repelling. Push means to repel. And when we think about a pulling force, this time when we talk about magnets, we're going to call it attracting. So push means to repel, pull means to attract. Alrighty, so on the bar magnets, remember on every bar magnet there was a north and a south. And if I have a north and a south on this one, here we have a south close to a north. That means that those magnets are going to pull together or attract. So they're going to pull together or attract. Alrighty? Now, I have another set of magnets, north and south, but this time I'm going to put south and north. So now I have two magnets that have the same pole near each other. So this time, instead of pulling together or attracting, they are going to push away or repel. So this magnet is going to be pushed away, and this one's going to be pushed away, and they will repel. Okay? So this is a really big idea in magnets. Magnets can pull together or attract. Magnets can push away or repel. That's so cool. Okay, so this is one of the cool things that I like about magnets. Well, there's a lot of cool things I like about magnets. But magnets don't have to touch each other to have the force act on each other. So if I have these magnets in my hand, they're not even touching, and I can feel them pulling or attracting on each other. If I flip one over and I put them near each other, I can feel them pushing away from each other. And I can use that idea to make a fun little trick. So I'm going to take a donut magnet, and I'm going to put it on my pencil. And I'm going to take another one. Uh-oh, wrong side, because they stuck together. I'm going to take this one off and flip it over. Aha! This time, my magnets appear to be floating. But they're not floating. I mean, they are. But what's happening is that these two magnets have the same charge, or the same poles near each other, either south and south or north and north. And because they're the same pole, they are repelling. Now this is the cool thing. Which force is stronger? The pulling force of gravity or the magnetic force? Well, I think this example shows you that magnetism is a stronger force than gravity. Because if gravity was stronger, these magnets would not be repelling. This magnet would not look like it's floating. All right, so that's one fun thing. The other fun thing to do with magnets is that they travel through something. So I've got some paper, and I'm going to put a magnet on this side, and I've got a magnet on the other side. Shh. And I can make it look like this magnet moves on its own. Because I'm not actually touching that front magnet. I'm touching that magnet by touching the other side. These two magnets are not touching each other. Do you see? There's space, there's paper between each one. But because magnetism can actually travel through materials, you can do a magic trick and make it look like you are controlling the magnet with your mind. Just really with the other magnet, right? So that's cool. Magnetism is stronger than the pole of gravity. And magnetism can travel through different materials. Magnets are pretty awesome. So boys and girls, you might not have donut magnets at home like I do. You might have just some magnets that are on your refrigerator, or maybe your parents have some magnets on some other things. But all magnets have the same parts. All magnets have a north pole and a south pole. All magnets follow the same rules. When they attract, it's opposite poles attract. When they repel, it's the same poles repel. North and north, or south and south. Now, these are donut magnets. You might have some bar magnets. Same rules, right? Two north poles, they repel. Two south poles, they repel. North and south, they attract. We're going to use this idea of magnetism and repelling and attracting as we start going towards electricity. Because pretty soon we're going to start learning about electricity and how electric current works. We've got to know and understand the idea of attracting and repelling. All right, Cougars, see you next week.